Okay, hello guys. So today we're gonna hopefully you have a calculator or your phone, because your phone has a calculator that will work. And we're gonna be exploring the graphs of some periodic functions. So we're going to be going through sine and cosine. So it's gonna be a weird one because it's super hard to draw right now on the function am. So I'm gonna go back to like the answer key. So I'm gonna do the first couple with you guys, and then we're gonna go back to the answer key. And then you can kind of copy it off then. And I think that's the best option for us. Okay. So let's go through literally we're going to go through the first two. I'm going to plot them on here. And then you can copy down the rest. Okay. So now I want you to grab your handy dandy calculator. And I want you to take your calculator, whichever one. Sorry, mine has to go sideways. And if you're on a phone, you're going to press 0 sine. If you are on a calculator, you're going to press sine 0, I'm pretty sure, okay? So 0 sine, no, your calculator did not break. It is 0. So I don't want you to think like, oh my god, my calculator. Yes, it is 0, okay? So that's going to go there. I actually want you to write it in two places. So 0 there, and I'm going to write it 0 here. Okay? So, oops, that's not the one I wanted, this one. Now I want you to take your handy dandy calculator and I want you to click 30 sine. You're going to get 0.5. Oh, weird. Weird, weird, weird. I'm also going to get you to do a review of the first lesson we did, okay? And that is converting degrees to radians. So, I don't know the symbol for pi, so remember pi over 180 degrees is the same. They're the same thing. Pi is half a circle. 2 pi is a full circle. That's what we learned. So we need to convert this 30 to pi. I want to see pi in there, okay? So this is what we're going to do. I'm going to keep this little cheat sheet right there. And so let's set it up first. So 30 degrees. And we're going to times that by pi over 180 degrees. So degrees has to be on the bottom in this case, like it is, because you want to cancel out. You just want to be left with pi. You just want to be left with radians. The thing that's different with this is last time we were solving for a decimal. This time I actually want a nice clean number. So I actually want pi in all of them. And what that means is we're just going to divide the degrees. Or that's all. We're just going to leave pi. Pi is going to be a constant throughout. All these should have pi. You can either write pi like I am, or just write the symbol. The symbol looks cooler, so I would do that, but that's me. So pi. Now we got to figure out what is 30 divided by 18. Here's my trick with math. When you have a smaller number dividing a bigger number, you always get an ugly decimal. Right now we don't want an ugly decimal. So what you're going to do is you're going to go 30 divided by 180. But you're going to kind of flip it upside down. So you got to think in your head. What is 180 divided by 30? That is 6. And now we're going to put that 6 where the bigger number is. The 180 is on the bottom. So we're going to put it right there. Pi over 6. Okay? So that's the thing, the degrees. You can take time to do that to actually all of them. That would be really cool. I am going to give you a screenshot of it. But I would like you to try it because it is a refresher of the first lesson. Now, let's plot these 2 points. I know this is going to be a bit weird. Let's use pink because, like, why not? So, sine start when it's 0 degrees. Here's if you notice these are degrees. It was just at 0, so that was kind of boring. We didn't really move. Fun. So much fun. Stay at 0. That's our first point right here. I can't pick it up. Right there, right? When we're at 0 degrees, we're just at the decimal 0 right here. Whoops. Can I pick this guy up? Yeah. When we're at 30 degrees, we're at the decimal 0.5. So it goes right here. Okay, so that's how we're going to get this graph. Now, because it's so hard to teach it like this without a pencil, I'm honestly going to show you the key, and you can copy down the sine graph. Oh, there's... Okay, so this is what I meant by when I said pi. So right here. So I wanted you guys to try this on your own, but you can't copy it right now. You can pause it. So right here, we're just literally converting all the degrees into radians by doing our nifty conversion factor. So right here, 60 divided by 180 gave us 3. That's how it was. 90 divided by 180 gave us 2. 120 divided by 180 gave us 2 over 3. 150 divided by 180 gave us 5 over 6. 180 divided by 180 is just 1, so it gave us pi, right? So this is how we're getting these numbers. And then, remember those decimals I was getting you guys to get on your calculator? These come in super handy because they help us plot this. Look how beautiful this sine graph is. Going through, this is actually just a circle. Do you see that? Now, this is if we took, this is like mind-blowing. But it's like if we took each of these points that we just got here, like sine 30, sine 60, sine 180, and we plotted it here, this is like we kind of cut the circle and we stretch. We started here and we stretched that circle, all the points. And this is where they would line up to. It's beautiful. I love it. You guys can pause it, copy this down. And then we're going to do it to the cos graph, which is going to be different. So the cos graph, all these numbers, these pi numbers are going to be the same. Okay? They're going to be the same. What we're going to change is actually these little numbers right here. Okay? So that's super key. And I'll show you what I mean, because look. Right here. So if you notice, I have 2 sine graphs. That's my bad. I didn't mean to do that. I forgot the cos, something messed up, okay? But when we go here to the cos graph, these radians, these numbers right here, are going to be the exact same, okay? So please put them the exact same. Please, please, please put those the exact same. The difference is going to be the radians. Also, which is going to be the exact same, are these little drawings, these little green marks. Okay, the green marks are going to be the same, so I need you to copy those in as well. The only thing is different is we're going to find... The cat was doing something, sorry. We're going to find the decimal, okay? So the first one, let's find the first decimal. So we're going to go cos 0. Ooh, it's 1. I love that. Cos 30. 30 cos is 0.5. Did I hit cos right? 30 cos. Yeah, there we go. 0.866. 0.87 we're going to round it to. What is it? Next one. 60 cos. That's 0.5. Let's do 90. So remember, these blue numbers, those pi's are the same. So please tell me that you already copied that down. 90 cos on our calculator is 0. Oh, weird. Oh, weird. 120 cos on our calculator is, negative 0.05. Oops, 0.5. My bad. Oops, I skipped 150. 150 cos. Cos is negative 0.866. Now, I'm going to stop there. So, I don't know if you guys have noticed the difference, but these 4 numbers have literally just been cycling. Okay? So we have 0.5, 0.87, 1, 0.875, 0, 0.5, negative 0.8, or negative 0.5, negative 0. Yeah, if you notice, like, those have just been cycling through. So you can kind of predict before we do 180 what it's going to be. All right, so you can kind of predict 1.87, 0.5, 0. And I hope you were like, oh yes, Miss Harper, I can predict that. Because we're kind of like actually going through this circle. So we actually start up here. We start off at 1. And then we go to 0.87. So I hope that you all said -1. Now for this one, I hope you're taking a guess. It's going to be negative point. So 210. I hope you guys all said negative 0.87. Because after 1 came 0.87, 0.85. So yeah. And I hope for this one, you guys all say negative 0.5. Oops. For this one, I hope you say I'm like, I don't know why I'm leaving space for you guys to talk when you're not here. Bill said 0. And then right here, we're back at the positive 0.5, 0.87. Again, if you don't see the pattern, that's okay. Just punch it on your calculator and you'll be getting these numbers. Don't feel bad. You'll see it. You'll see it. Okay. So there we go. Remember, all these top ones you should have down. It shouldn't be blank like mine. You should have copied, pretty much just rewrote it. Now let's get this beautiful graph going. So the main difference is the sine graph started at 0. Okay, that's one of the key things I want you to know. Sine starts at 0. The cos, on the other hand, the cos starts up at the top here. It starts at 1. So it's kind of like actually, oh, grab it. I'm so mad. Okay, yeah. It's kind of like if I were to, let's go back to this. If I were to able to like pick up each point and like have it in my hand and like just place it like one thing higher, I would be able to place the graph. Starting right here. It may not look like it when it's done, but like that's pretty much what you're doing. So it's pretty cool, but let's just keep plotting some points. So at 30, we are at 0.87. So that's like right here. Wow, my circles just keep getting like sadder and sadder. I'm sorry, guys. That's definitely at 0.87. Okay. And then at 60, it's 0.5, so it's right here. At 120, it is at negative 0.05. Oops, I skipped 90. You goose. 90, it's at 0. At 120, it's point right there. Okay, and then at 150, it goes down to almost -1. 180 is our -1. Yay. 210 is negative 0.87. 240, -5. 270 is 0. 300 is 0.5. 310 lines up right there. And lastly, it's like 360 is 1. So it's like a little bell, an upside down bell. Which again, if we were just picking up from here to here, we would just literally be able to pick it up and just shift it up. Draw a line through it, make it look cool. Again, we have the decimals here. Please put the radians up there. You don't have to recalculate them. Obviously, you know them. But that's that. So that's the beautiful, whoops. That is the beautiful sine and cos graph. I really like sine and cos graph. So now the main thing that we're getting to, can't zoom in. Haha, computer froze. Cool. There we go. Is how to label these 4 things. So we're going to talk about periodic function, the midline, the amplitude, and the period now, okay? And then your assignment will be in the textbook at the end of this paper. Email me if you don't have a textbook and you need like a picture of it. I'll quickly send it to you, okay? So now we're just going to talk about characteristics of a graph. So like if you characterize an apple, you know, its circle has a color of either green or red, has a little stem. Those are characteristics. Now, if you characterize sine and cos graphs, you're going to be talking about these four main things. So a function is where the graph repeats on a regular interval or cycles, so the period. So right here, this is one whole period. Okay, and it actually just repeats after that. The sine graph will literally go on forever. It like literally goes on forever. Same with the cos graph. It like literally goes on forever. So that's one period when it continues one full cycle and then all of a sudden it repeats. So right here, I know I'm using something that's not there. So right here, it starts, here's one period, starts at 0. And this period will end at 360. And then if you notice, it will continue going on. So that's that full period right here. It's and then an interval would just be right here. This is one interval doing one of these curves, okay? So that's for the first one. Delete these. The midline is just that. It's literally just the horizontal line halfway between the maximum and minimum values of your periodic function. So if we just looked at our regular graph right here, the midline would actually just be 0 because it goes down to -1 and 1. The difference between those two graphs, like the middle of those two graphs, is 0. So 0 would be our midline. It doesn't really show really well here, so that's why I went back to that one. So again, max and min, there wasn't a definition for that, but that's I felt like that was pretty straightforward. It's just your highest value on the y and the lowest, so I can clear that up later if you need me to. The amplitude is the distance from this midline to either the maximum or the minimum. So in this case, our amplitude is just 1. Like if we go back to this one, it's just 1 because it's one's full space here and one full space here. So you could have either like a smaller graph or a bigger graph, depending on whichever one you're doing. It's always positive. So even though you go down, it doesn't mean it's -1 amplitude. No, it's just a 1. And the period is the length of the interval of the domain in order to complete the cycle. So it's literally just up here. So like one full cycle is from 0, right here, this one would be from 0 to 360. Boom, we completed the cycle. Okay, so let's go through some examples now. Right here, and if you notice, here's your assignment, okay? It's in your workbook. So correctly label the min, line, maximum, and min points, amplitude, period for the graphs below, and state if it's sine function or if it is a cos function. So right off the bat, this guy starts at 0. Remember the key thing I told you, if it starts at 0? This is a sine. I should have prefaced, pause the video. Try to get these all down before I finish. But this is a sine function. Okay? This is sine. Starts at 0, it's sine. So again, pause the video. You do the rest, okay? But let's go through the rest. So our max is right here is, so our max, this graph ever goes, where's the hand? Okay, you know, it's pretty close. So the max it ever goes is 2. So it just goes up 2. The min it ever goes is -2. So I'm going to pop one down there. There's the hand. So that's the min it ever goes right there. 2 and -2. Okay, so that's literally max and min. We did it. We did it. So, oh, my back hurts. Let's do the midline. In this case, so it's 2 from here and 2 from here, so the midline is actually just 0. It just cuts in right down the middle, just the middle of that from here to here. I'm going to pop this to be red. I think that'll be a nice color to choose. Choose the wrong one. Right there. So the midline is 2 up, 2 down, so that means that's the middle. Again, midline is just the middle, right? The amplitude. So remember, the amp is literally just the space between the midline and either the max or the min. So like you just decide. I'm going to do the max just because it's easier. I'm going to do it in blue. So that amplitude there is just, it's just 2. It's nothing crazy. If you notice, these are all relatively the same. It's just 2. And then we gotta do the period. So where this guy repeats. So there are a couple periods in here. You can either do the period from, like you just pick whichever one. So you can literally do it from, the easiest one would just be from here, copy UV to here. Let's see, right there. So from 0 to 6, or you can literally do this too, just so I'll show you. You can do it from here to here. That's another period, just like that does an interval, and then it repeats. So wherever it repeats something, right? Or you can do it from this guy to this guy. Yeah, so it's literally from, I should have used different colors. Definitely use different colors, Miss Harper. So from this, definitely not pink. This burgundy to this burgundy is a period. And then this green to this green is a period. So those ones are just different, okay? All right, we'll do this last one together, and then you'll have the homework. So this guy starts at 1, or this guy starts not at 0. So when it doesn't start at 0, it is a cosine. Okay. I'm not going to be drawing anything on this just because it got really, really confusing. But the max, it doesn't, the max looks like it's 3. It doesn't cross that. The min goes down to -3. So it doesn't cross that. Midline for this one, so it goes up by 3 and down by 3. The midline is then equal to 0. So another cheap midline. You'll be looking at a lot more. And the amp, well, that is 3. The period, so these ones I will draw in. So like we could have, so remember the period is wherever it repeats. So from right here is a good period. Oops, I didn't want to copy that guy. Or you could do it from there to there. Or from there to there. So you can pick any period you want. That's literally up to you. You know, there's one from right there to there, or like there to there again. So literally, whichever one you want, as long as it repeats. Okay, so there's your assignment. Email me or like message me if you need it. Send in a picture to you. Okay.